All right. I need to start today by making sure everyone's calculator is set up how it's supposed to. There's a setting on your calculator that I want to make sure everyone has correct. Here's the quick, 30-second version for what your calculator is doing. There are two different ways that we talk about angles. In geometry, we talk about it with degrees. All the way around the circle is 360 degrees. Straight line is 180 degrees. And we look at how many degrees the angle makes up. There is another way we can talk about angles called radians. And the basic idea is instead of having 360 be all the way around the circle, we talk about walking around a circle and how much of that arc we have walked around, that distance is our angle. And we measure that in something called radians. And that uses a different measurement. So we won't talk about that in this class, but what you need to know is that your calculator needs to know when I talk about an angle measure, which measurement are you talking about? And we want to say, well, we want it in degrees. So you need to make sure that your calculator is doing things in degrees. So if you have a graphing calculator, then the way that we're going to make sure that that is changed is that you're going to go into mode. Mode is basically the settings menu of the calculator. You're going to go into mode. We have a whole bunch of functions. And the choice that we have is radian versus degree. We're going to go on degree and select it. And then exit out of the menu, second, and quit. Some of you, for the calculator, it might have a button that says DEG. It just depends on what kind of calculator that you're using. That's why I wanted everyone to have out a calculator so that you could follow along and make sure that this is correct. The test that we're going to use, we're going to use our 30, 60, 90 pattern. So very quickly, to review our 30, 60, 90 pattern, if this is 30 degrees, if that side across from it is 1, remember our hypotenuse was double, and this side was square root of 3. So what I'm going to use is I'm going to use sine of 30. Because sine of 30, across from it is my opposite, is 1 over my hypotenuse, which is 2. So the answer should be 1/2 because of our 30, 60, 90 pattern. So this is what I want you to test before you do your homework or take any tests that involve the trig. Because otherwise, if your calculator's on the wrong setting, then you're going to get all the wrong answers. So make sure that this setting is correct. So we're going to test sine of 30. You should get out 1/2 or 0.5. If you're getting out any weird decimal other than 1/2 and 0.5, then your calculator is not in the right setting and you need to fix it. If you need help with that, let me know now. Because again, it'll depend on what kind of calculator that you have. So right now it's in radian. It's right here. RAD or DEG. We want DEG. So let's try it again. There you go. So it's right over here. Which one do we want? We want degrees. Well, then you'll have to figure it out later. If you do not have a calculator, you're going to need to figure this out separately. If you need help, let me know. but you will not be able to do the homework or any of the work that we're doing in this chapter without a calculator. Make sure you have a calculator. Anyone else need help with their settings and making sure they're in degree mode? All right. Then let me show the answer to this next problem for you to check your work. Remember that sine and cosine and tangent change depending on which angle we're looking at. So when we talked about angle J, here was my angle across from angle J, my side across from angle J. That's my opposite. When I talk about angle K, this side becomes my opposite. This becomes my side that's across from angle K. And then we simplify them. And then it asks, what do you notice? What happened is, if you looked at this problem versus the last problem, is that these simplified to all the same things that this problem up here simplified to. So the triangles were similar. Scale factor was 4. So that meant that angle J here and angle J here were the exact same angle. Now here's what we're going to do going forward. We are going to use a particular trig function, either sine, cosine, or tangent, based on what pair of sides I care about. So you'll need to pick out what pair of sides am I interested in, and what ratio does that mean we're going to use. We'll practice a bunch of them tomorrow. We'll just spend tomorrow drilling these and making sure you know what to set up. But for that, you need to know which thing goes with sine, which thing goes with cosine, which thing goes with tangent. Here's a kind of common memory trick for remembering which one's sine, which one's cosine, which one's tangent. And that is SOHCAHTOA. Just a memory trick so that you know which one goes with sine, which one goes with cosine, and which one goes with tangent. SOHCAHTOA. So, sine is opposite over hypotenuse. Sine goes with opposite over hypotenuse. So, cosine goes with adjacent over hypotenuse. Cosine goes with adjacent over hypotenuse. SOHCAHTOA, tangent, goes with opposite over adjacent. So that's a trick. It's going to be over here as well for you to be able to remember which thing goes with what. Remember, I said yesterday, for sine, opposite has to go on top, hypotenuse has to go on the bottom. Otherwise, it's not sine. But this is what we're going to practice looking at over these next couple days. We're going to be interested in a particular pair of sides, and based on those pair of sides, we're going to say, oh, right now I care about adjacent and hypotenuse. So which one's adjacent and hypotenuse? It's cosine. And so we're going to use cosine for that problem. That's what we're going to start to do. I'm going to say again what I said yesterday. What we're about to do is we're going to use angles that we know to solve for sides that we don't. We're going to use angles that we know to solve for sides that we don't know. Here we go. For this first one, I'm going to solve for both variables. I will not do that in every problem because it would take twice as long. Going through one should be enough to give you the idea on each of these. We're going to be rounding our answers. It has to round our answers to the nearest tenth. So our side lengths here, we're going to round to the nearest tenth. Let's set these up. I'm going to start by looking at this angle. I have 57. I'm using this angle that I know to solve for the sides that I don't know. Here we go. This angle right here is 57 degrees. And now I want to pick out, based on that 57 degrees, which sides are what. First off, this side, longest one across from the right angle, that's going to be my hypotenuse. I'm going to label it H. And then we have our two legs. This leg across from the 57 degrees, so since I'm looking across from it, that's going to be my opposite. Then this one is touching the 57 degrees. It's right next to it, so it's going to be my adjacent. So now we have labeled our opposite, our adjacent, our hypotenuse. I'm going to start by solving for A. And I'm going to use the part that I already know, which is the 14. So those are my two sides that I care about right now. I care about the 14 because I know it, and I care about the A because I'm trying to solve for it. Right now I'm trying to solve for A. I don't care about B right now. I will in just a second, but right now I don't care about B because I'm not solving for it. So what do I care about? I care about the 14 because I know it. I care about the A because I'm trying to solve for it. In other words, I care about my opposite and I care about my adjacent. So when I'm deciding which one to use, I know right now that I care about opposite and adjacent. So I'm going to go over to my trig and say which one deals with opposite and adjacent. And that's the one we're going to talk to. Opposite and adjacent, that's tangent. Tangent deals with opposite and adjacent. So we're going to use tangent. Of the angle here, we know it this time. Usually we've been using the letter because we don't know the angle. But this time we know the angle, so we're going to put in the angle. It's 57. Equals opposite over adjacent. Opposite goes on top, adjacent goes on the bottom. On top is my opposite, which is 14. On the bottom is my adjacent, which is A. That's my setup. That's what we're going to spend a big chunk of time practicing tomorrow, is getting those setups and knowing whether you use sine, cosine, or tangent on each problem. Okay, today, what I want to talk about and make sure we get down is how to solve. Because that's the stuff I'm going to kind of breeze over tomorrow. So make sure that we understand the solving process that I'm about to do. It's going to be a very similar process that the solving was for some of the equations we had a couple chapters ago, which is I've got a fraction there. I don't like fractions. I want to get rid of that fraction. How do I get rid of the fractions? By multiplying by what's on the bottom. Because a fraction is just division. So if I want to undo division, I use multiplication. So to get rid of the fraction, we're going to multiply by whatever's on the bottom. Right now, what's on the bottom is a. So I'm going to multiply by a on both sides. And that'll get rid of the fraction. So on this side, we just have 14. On the other side, we've got a times the tangent of 57. The big thing to know about these tangents and these trig functions, tangent of 57, let me show this in the calculator real quick. Tangent of 57 is just a number. It's going to be some big fancy decimal. 1.53986, I don't really care, but it's a number. It is a decimal. So in the equation, you're going to treat it like a number. So this thing is a number. So if I'm thinking about how to solve this equation, I have a times a number equals 14. How do I solve that? Well, if I have a times a number, then I'm going to get rid of that by dividing by that number. On both sides. So I'm going to divide by tangent 57 on both sides because tangent 57 is just a number. A equals 14 over tangent of 57. This is the exact answer with no rounding, but we're going to round it. We're going to round it to the nearest tenth, so we're going to round it to one decimal place. Here comes the calculator. 14 over the tangent of 57. Close your parentheses once you're done with tangent. 14 over that decimal, 9.0917, which one decimal place we're going to round to 9.1. Questions on that? I'm going to do the same thing here, but I'm going to do it a little bit faster this time because the process is going to be very similar. If I lose you, stop me and let me know. All right, now I care about B. I don't care about A because I already solved for it. Now I care about B. So now what sides do I care about? I still care about the 14 because I know it. And now I'm trying to solve for B. So what I care about is B. So which two sides did I just mark in blue to say that I care about? I marked my opposite because I know it. And I marked my hypotenuse because I'm trying to solve for it. So right now I care about opposite and hypotenuse. So which one deals with opposite and hypotenuse? Opposite and hypotenuse, that's sine. So we're going to use sine. because we know opposite, we want to find hypotenuse. Sine of my angle equals, my opposite is 14 over the hypotenuse, which is b. We picked sine because we know opposite. We want to figure out the hypotenuse. And sine can talk about opposite and hypotenuse. We're going to solve the equation. Again, I'm going to do it a little bit quicker this time. I've got a fraction. I want to get rid of it. I get rid of the fraction by multiplying by what's on the bottom. So we're going to multiply by b on both sides. B sine of 57. On the right side, the b's cancel, and we don't have a fraction anymore. We just have 14. Get rid of our multiplying, because we have b times some numbers. Sine of 57 is just a number. So we have b times some number. How do we get rid of that? By dividing. So b is our exact answer, 14 over sine of 57. And we're going to round that answer in our calculator. (14 over sine of 57). 16.7 is what we're rounding to. So, questions on this so far? All right. Going forward, I just want to do one of the things that we're trying to solve for. So I'm going to take a look at this next one. I'm going to try and solve for x. So I'm going to give you about 30 seconds. If I'm trying to solve for x, try and pick out, are we using sine, are we using cosine, or are we using tangent? That's what we're going to practice a lot of tomorrow. We're going to go down the line of all of these and make sure you know whether we're using sine, whether we're using cosine, whether we're using tangent. Label your sides. Right now, I don't care about y. I'm not trying to solve for it. What do I care about? I know across from the 43, that's my opposite. This is my leg that is touching the 43, that's my adjacent. I know opposite. I want to solve for adjacent. I know opposite. I want to solve for adjacent. So opposite and adjacent. Which one knows opposite and adjacent? That's tangent. Tangent of my angle. Equals my opposite, which is 36, over my adjacent, which is x. So let's solve there. Multiply by what's on the bottom to get rid of the fraction. And then same deal we've had before. X times, this is just a number. So to get rid of x times a number, I divide by it. And then I need to put that in my calculator. 36 over tangent of 43. $38.6. So that step in the process, once you have the setup, we're going to solve it by multiplying by whatever's on the bottom to get rid of the fraction. That's the process that we're going to need. So hopefully we're comfortable with that solving with the multiplying by whatever's on the bottom. I might do it on one or two more, but tomorrow I want to focus on the setups.